好的，不管你了啦，不管了。我刚刚其实是在烦恼说，这直播出去，我还要剪片，因为我不想让你学对面看到这个东西。好，没关系，算了，从这边开始。应该自己看得懂吧？好吧，通常最有问题的是这个。And the biggest problem comes from here, so I think it's okay. Okay. So usually, I start from the senior high school part. So usually the students have problems. They just this is not wrong. When you have the voltage applied on your wire, and there is a kind of electric force driving your charges moving on the wire. And actually this is called the electromotive force, and we're going to introduce it in the next lecture, I think. But when you are talking about the electromotive force, you have to specify you are working on electric field on the z direction. Z direction in this case is along the axis of your wire. 所以如果你在回答的时候，你想要告诉我们是关于这个 electromotive force 的事情，那么请你要在答案里面你要写明白说，我现在在讲的电场是沿着wire 轴向的电场，就是我现在这边把它定义为 z direction。对，那这个我觉得这个是你要把答案说明清楚的第一步，不然的话，很多人都会觉得非常的 confused， 就说我以前高中的时候明明有跟我讲说，我加了电压之后，我的电场应该要跟我导线平行啊，那为什么我们现在跑到电磁学高斯定律，然后就又变成电场是零了？那个是因为你要看你在讲的是哪一个轴向，哪一个电场。好 ，and then the second checkpoint on this problem is if you are analyzing the EZ versus radial direction. This is a strange statement, but if you want to do it, we can do it as well. 这样子讲法，大家通常会觉得有点奇怪啦。因为我们通常都会把 EZ 就画在 Z 轴上面 ，ER 就画在 R 轴上面。对，但是如果你现在非常的有求知精神，你想要尝试看看，你要把 EZ 画在 R 轴上面也是可以。那它会出现的状况就会 ，then the situation would be like, just remember, even if your charges are moving and they are moving under just beneath the skin of your metal, they are not flowing inside the wire. It's still neutral at the center of your wire, and your positive charges and negative charges are beneath the skin, but they are flowing. 但是你想要做这件事情的时候，有一个观念你一定要很清楚的记在心里面。即使你的正电荷跟负电荷加了电压以后再移动，它们也是在金属皮下面那薄薄的一层在移动。这些电荷并没有在电缆的里面，它没有在电缆的肉里面动，它是在电缆的皮上面流动。那你抓紧了这个概念之后，你就一定可以画出来。If you have that kind of correct concept in your mind, and soon you'll realize that the electromotive force, the EZ, should be zero at the center of your wire, but just on the skin, then it goes up. It has a certain number. It depends on the length of your wire and the voltage you applied, but just outside of the wire, then it goes to zero again. So, if you want to draw EZ versus R, the curve should look like this. 所以如果你想要画的是Z 方向的电场，也就是 electromotive force 的话，它长的样子应该要是这样，就是你的电场它只有在电线的皮下面那一小段区域有，电线的肉里面是没有的哦。好，所以这个是你要注意的地方。Okay, so here's the summary. So for the answers of problem 1.3, I designed the question like this. it's basically just like free thinking. So I don't have any expectations on you, but I just see how deep and how far you can go. 我那时候在设计这个题目的时候，我没有告诉你什么 ER、EZ， 然后或者是怎么样 boundary problem， 我都没有告诉你们，因为我想要保留一个自由度，让可以想得深、想得远的同学进行发挥。所以我们那时候我没有特别，因为我觉得这个题目你讲 ER、EZ 就没意思了。大家可以懂我的意思吗？就有的同学他想得很深，他是可以想出很多我们想都没想过的答案的。我不想要把那种同学的创造力扼杀掉，我觉得这样子太没意思了。那我们那时候，我通常在让大家做这题的时候，我本来心里面排的剧本是这样啦，就是 so actually the drama in my heart is like this. So if you're a hard-working student and then if you follow the instruction from the textbook, and basically you have to have the answer like this. So the 1 and 2, the checkpoint 1 and 2 should be correct, the checkpoint 3 should be correct, and the 4, and just as said, you have ideal cases and realistic cases. So if you draw it and if you do some imagination, then you get the credits. So this is how we do the correction. We leave it free for your choice of ground, and we didn't do strict checks on it. If some student just left it blank and didn't do anything, then he didn't get the point. So it's like that. And here is like if some students want to work on the electromotive force, the electric field on the z direction, on the x direction, and if they just think about it and if they do the right curve like this, then they will have a bonus. So this is how we manage this question. Okay, so here's a reference answer for you. And I'm sure, even if I've been running this problem for 2 years and then we are still collecting creative answers. So this is an question like this. 所以我去年有考过这题，我今年也考过这题。然后我今天光这题我就讲这么多，是因为去年有很多同学给了有趣的答案，今年也有很多同学给了有趣的答案。那我相信，就算我明年再考这题，应该也还是有同学可以给出新的洞见。所以这种题叫洞见题，就是 we are collecting insights from this kind of problems. Okay, so you can check your answer, and if all of these answers and give you new inspirations, then you can do the record. 好 and let me rest for a while. Okay. And this is problem 1.3. And this is problem 2. And on problem 2, let me just tell you the checkpoints. In the recitation, did the TA tell you the checkpoints of this problem? 在做 recitation 的时候，助教有没有告诉你们他检查的5个重点？有哈，那我就不用重复了。OK， 好。那么 then 那这题就给大家看一下一个我觉得很疗愈的答案。So this is the answer. I like it very much. The physics is very clean and clear because she just indicated all of her thoughts on the graph, and then he just drew every detail and explained all of her process of thinking. This is a very good answer, though there are some little details which is not really perfect, but I think it's perfect enough for a freshman. 就是像这样子的答案哈，它其实有一些小细节其实是不是很到位啦，像这边就是你的电场线应该要稍微再弯一点，稍微有一点点垂直的这样子进去那个表面。它没有真的画嘛，但是我觉得对一个1年级的大学部学生来讲，可以画到这样子的程度，思考细腻到这种程度已经很完美了。好，然后它的 它的图像表达能力也非常的好，所以大家可以参考这样子的答案，这个做得很棒。OK， this is a question maybe on the third year of your universities, and then you have to apply there's a name in mathematics for Laplace equation in the spherical coordinates, but I suddenly forget what's the name. Causal or let me check for that. 怎么突然之间脑筋跳电？明明这么重要的事情，我怎么忘记？equation, spherical coordinate. So there is a series to solve this. What the hell is it? Sorry. 对不起，我真的突然之间忘记了。Here's the answer: the Legendre polynomial. But there is still a name for the series like this. 我怎么突然之间忘记了？对不起，让我执着一下。它的解应该是一个叫什么？哦，贝索方程，叫贝索方程式。对，我终于想起来了，贝索方程。OK， 贝索方程。So you will learn Basel function in the second year of your university, and I think on the second semester in the second year, or on the third year, you use the Basel function to solve the shape of the electric field like this. 所以你应该是会在公数里面会学贝索方程，还有 Legendre polynomial。然后你学会了以后，那你就应该是大三吧。如果是电磁学的话，你就要用那个贝索方程，然后去把这个放射状或者是球状的电场把它画出来。好，终于想起来了。Okay, and then here are the questions. Problem 3 is very solid, so with very clear answers, so let's just keep it. And then it's the last problem, electrostatics in everyday life. Okay. And I think you soon realized I will put a very high standard for the problem 4. So many people get surprised when they have the credits. 大家看到考卷一定会发现，我们在改这些题目的标准是蛮严苛的哈。对，所以因为我们已经上大学了，我们看的问题的深度要深一点。So we start from problem 4.1. So rubbing against the fur of your cat, and then the fur attract fragments of paper or little balloons. So what happened? A question like this is that I would like to see how far you can go. 所以这是一个问深度的问题。对，你就是看你最深可以回答到哪里，我们就给你几分。好。And I start with the English version. So, Coulomb's law, I think this is more or less like a common sense and everybody knows it. So, this is just common sense and everybody should know it. But I'm sure we learned dielectrics, we learned polarization, and we learned how polarization changes electric field in dielectrics in the lectures. So I'm sure you can go deeper into this problem. And actually, maybe you can ask yourself. So actually, I think this question is quite common from those boys and girls who are very observant. 就是一些观察力很敏锐的小朋友， 通常就会问你一个问题，他就会问说 ，So if the positive and negative charges get in touch, so if there are positive charges on the little fragments, and if there are negative charges on the cat, and positive and negative charges, when they get in touch with each other, they should disappear, isn't it? Plus and minus and annihilate and disappear. And then the charges disappear and Coulomb's force should disappear too. But apparently it's not disappearing. It's still there. And why the paper keep attached on the fur? And if you put in more little pieces of paper, and it just attracts more and attaches more, and it seems like the charge is never neutralized. 就是这些小朋友就会问你一个很重要的问题，他就会问说，不对啊，正电荷跟负电荷，他们两个一 touch 起来，中和不就消失？啊，消失之后，互伦力也就消失了啊。可是现实就不是这样子呢，好奇怪哦，为什么会这样？就是如果显然正负电荷并没有消失，因为这些小纸片它还是粘在猫咪的身上。而且如果你现在拿另外一些纸片再继续粘，它只会越粘越多，然后这个状况并不会消失啊。到底发生了什么事情？答案就是其实它不是单纯的正电荷一颗一颗，负电荷一颗一颗接起来，然后就吸在一起这么简单的事情。它其实有牵涉到这些小纸片，或是这些小气球的极化。So the real answer is related to the polarization of the little paper and the little balloon. So that's the reason why you can think about the polarization in dielectrics. So even if they get polarized in an external electric field, but all of the charges are in space, which is confined inside dielectrics. So even if your positive and negative parts are attached, they have a boundary on the surface. So all the charges, they don't unite and they don't annihilate. Okay? So checkpoint 1 is for the answers in the range from rubbing and how the charge is generated to the Coulomb's law. So if you just answer it until the Coulomb's law, then you have the check number 1. And if you can think deeper, if you can think of the charges on the fur of the cat, they generate electric field, and that electric field polarized the papers and then polarized the balloons, and then so on and so on and so on. And then you can get the checks from the check number 2 and 3 and 4. Okay, so 2 and 3 and 4 are for the people who apply the knowledge in dielectrics. Okay, and usually you can have more interesting ideas like explanation for how the charges are excited by rubbing, or some other insights, then you will have one more check. Okay, so this is how we correct problem number 1. 好，所以如果说你思考的深度有进入到介电值，有进入到极化，然后甚至呢，如果你有一些很有创意的答案，比方说我之前有讲得更深的，就是你在摩擦生热的时候，你的热会把电子缠起来，或者是你有一些别的有趣的答案等等呢，这些状况你就会得到更多勾勾。好，所以这个是小纸片的问题。所以这是一个很典型的，你表面上看你觉得很简单，但是实际上你很认真去分析它的话，可以讲得很深入的问题。Problem 4.1. And problem 4.2 is just on the lecture slides, you can check through it. 那么第一个小题在上课的投影片里面有，所以你可以直接去看答案。好，那这部分我就不再多做解释。第三题呢也是个，你如果看到网络上的讯息，你傻傻的就相信，你就中计了。 here is another question that if you simply believe what you search on Google, then you just somehow get into the trap. So you have to use a little bit of your knowledge to understand if the knowledge is correct or not. So the biggest problem is if we are now the capacitive touch screen. So you can see the word capacitive. This is based on the capacitance of the human body and the capacitance of your screen. So this is all the physics behind it is based on induction, but not conduction. So many students somehow they get the concept of conductance touchscreen or resistive touchscreen, and they get all the answers wrong. And I think this is something that when you are checking the news or if you're checking the newspapers on the internet, and then you have to use a little bit of your physical knowledge to say if it's right or wrong. And 好，我这边解释一下哦。你如果在网络上面你去做搜寻的话，这题是有很多雷区的。大家可以想一下哦，就是电容式的触控萤幕跟电阻式的触控萤幕。那我们在上课的时候有讲过电容跟电阻的原理嘛？那如果在你查到的讯息之中，它告诉你，电触控萤幕。比方说，手机的触控萤幕一定是电容式的。那手机的触控萤幕，它在解释的时候会说，你的侦测器侦测到的是你的从手指流进 sensor 的电流之类的，你不会觉得怪怪的吗？就是为什么电容式的萤幕你讲到的会是从手指流进萤幕的电流呢？这不应该是在讲电阻式的触控萤幕吗？但是我发现就有确实是真的是有一些同学比较敏锐的，就会觉得是有蹊跷，他们就会试着去得到一个正确的解释。所以这题其实是我其实是不知道，我本来不知道在中文世界里面的错误讯息有这么多，所以我也是有一点点惊讶。那如果你查到的讯息是英文的，你就会知道说有比较高的几率会拿到正确的资讯。那这一份影片是我个人
How does swiping your finger across a touch screen make your phone or tablet work? It's all because of invisible electric fields that pop up out of the glass screen in a grid pattern. Those electric fields are monitored by sensors at the side of the phone, and when you poke your finger in an electric field, the field changes shape. When the sensors detect that change, the grid pattern lets your phone zero in on your finger's location. So what causes those pop-up electric fields, and what are they doing with your finger? The fields form around skinny wires that surround a layer of glass inside the phone. Whenever a pair of wires gets switched on, an electric field forms. One of the wires becomes positively charged because the phone battery's positive terminal sucks electrons out of it. The other wire becomes negative because the battery is pumping electrons into it. The wires are separated by the sheet of glass, and whenever positive and negative charges are separated, you get an electric field, and it's strongest where the charges are closest, where the wires cross over. Electric fields will push and pull on anything with an electric charge, and that's exactly what your phone's electric fields do to your finger. Your finger has got lots of positive and negative charges floating around in it, the ions from the salts that are dissolved in your blood and cells. The electric field around a positive wire pushes the positive ions in your finger away and pulls the negative ions closer. The negative charges at the surface of your finger balance some of the positive charge in the wire, and that lets the battery suck more electrons out of it. As that wire gets more positive, the battery pumps more electrons into the negative wire to balance the charge. So with your finger near the phone, the wires are more charged than they are without it.
So here, be careful. Your finger is a capacitance and the screen is another capacitance. These two capacitance are serially or parallelly connected. Sorry. They are connected in parallel. They are connected in parallel because you are connected to ground and somehow your phone is connected to ground, and then they should be in parallel. This is a point that I should always remind myself. But just be careful. Your finger and the screen, they are not connected. If they are connected, I'm sure you are constantly feeling electric shocks when you are touching the screen. Okay? 所以如果但是你的手指头跟你的触控式萤幕中间，照理说不应该有电流啦。你在弄电容式的萤幕的话，不然你每碰一下你的手机，你就被指一下，这样有点奇怪啦。那它实际上的原理 ，so the actual concept is that the charges stored in a big capacitor, so they got separated because they got affected by the electricity here. And here's another capacitor on your screen, and here's the negative charges, and here are the positive charges in his configurations. And these two number of charges, they induce the charges on your finger induce the charges in the touch screen. So here are the number of the charges in the touch screen, they change, and that kind of change versus time create a induced current. 就是你这些它的电荷的改变，它会产生感应电流，然后那个感应电流才是你的侦测器在侦测的东西，不是从你的手指流进去的电流，是你的手指感应出来的感应电流，这两个是有本质上很根本的差异。
Once the wires are switched off, the electric field disappears, so those electrons can flow back through the wires, evening out the charge. The sensors at the side measure how many electrons flow through the wires. If there were more than normal, they know something was touching the screen, and your device's processor can use the wire grid to pinpoint exactly which spot was touched. So the sensors can't actually tell what a finger looks or feels like. They just know how good at conducting electricity fingers are. They're programmed to ignore lousy conductors like plastic or gloves and really good conductors like metal, but they'll respond to anything that conducts like a finger. For smartphones, they're pretty easy to fool.
Okay, 所以这就是触控式萤幕的原理。第三题，好，这样大家应该明白了。再来最后一题 ，and finally, here is for the design of a power station. Okay, usually the questions is from checkpoint number 4 and checkpoint number 5. Checkpoint number 4, why a needle attracts the lightning. Okay, and here's the answer. So the needle is very sharp, and what's going to happen when you have a very sharp thing? I'm sure this is a section in the textbook, but sorry, I don't remember if I mentioned it I mentioned it. Okay, so with the question of the lightning and thunder. 我刚刚想了一下，我上课的时候有没有讲？有，应该有，我应该会讲，就是在那个在讲电容的时候，然后再讲到那个闪电的那个电弧放电的时候，应该有顺便讲。And here are two reasons why a needle can play the role to attract the lightning. The first is, if you have a very sharp thing, and if you measure the surface and divide it by the volume, and they have a very big ratio on it. So in a geometry like this, the density of the charge is very big, and the electric field generated by that kind of metal needle is very big too. And if you have a big electric field from your needle, then the air around it is ionized. And the bigger the electric field, and the more ionized air around your needle. Okay. And when you have ionized air and it gets somehow triggered, then you have the current running through it. So this is for the first reason. And the second interpretation is, if you have a needle like this, if they have a certain voltage on it, and if you have a ground somewhere, then you can try to draw the potentials, electric potentials from your needles, and you will find that just around the tip of your needle, then here's a place where the gradient of your potential is really, really big. So this is another explanation why we have it. If you have a big electric field, then the air around here got ionized easily. 所以你这里如果有两个原因会产生大电场，一个是说你的针尖上面的电荷，然后你可以想一下金属产生的电场，它会跟电荷的数量成正比嘛，电荷密度成正比，那这个时候它的电场本身就比较大。然后再来是针的形状，它会尖尖的，然后它那个尖尖的那个点那假如说我们在某个遥远的地方有一个地，那么从针尖到地那边它就特别的短，那段距离特别的短，然后它的电压的梯度就会特别的大，那电压的梯度就是电场，那你电场只要一大，你的空气就那个针尖旁边的空气就很容易会被游离，会变成正离子跟负离子。那你有正离子跟负离子在那边流来流去，只要你有一点点闪电那种电流这样子想要流下来，它很快就会找到平路，然后就会接到你的针里面去。所以这个是第二个原因。好 ，So this is why the sharp stuff is very easy to have electric arc， 电弧放电。好，然后呢，再来第五题 ，Explain the design of the wire. So how thick it should be. What about the materials and how to control the heat from big current? So we just learned the delicate version of Ohm's law, isn't it? You have the length, you have the conductance, you have the area. So if you can apply this kind of knowledge, then you can have a check. But just a reminder for you, for the problem number 4.4, we have 7 boxes for you. And we'll have a bonus for whatever of your consideration. But we have 10 point was scheduled for this question, but we have more boxes for you. So actually we have already given you a lot of bonuses. So don't worry. So if you have creative answers and if you are considering interesting things, and then you always have your credit. 然后大家可以注意4至4题，就是我们其实有7个格子诶，而且有一个格子是只要你有任何新的想法或任何你有新的考虑，你都会得到个勾勾。所以其实你要得到超过5个勾，我觉得没有那么容易，但是你够用心的话，应该都会得到满分。好，所以这是关于4.4，还有别的吗 ？Okay, so this is the end of the review. Okay, so this is 4:30. So I just stop here and I will stay here for 3 minutes. If you have questions or if you need corrections, then you can come to me now. 那我现在就是我在这边就会这边待半个小时。那你想要讨论、想要修改分数的话，那现在可以来找我。怎么讲那么快？那直播我就先停止喽。